For question 12, we have this projectile that is launched at an angle of 25 degrees above horizontal, and we're asked to figure out what the speed of it is at the top of its trajectory. What we need to realize is that at the top of the trajectory, that is just before it comes back down, the velocity in the y direction is equal to 0. And this is helpful because as soon as we realize this, we know that since Vx is conserved, all we need to do is figure out what Vx is at the beginning, and we have our answer. So what is Vx? It is the horizontal component of the velocity. We can find this by taking the cosine of 25 degrees and multiplying it by this velocity of 56 meters per second. So 56 times the cosine of 25 gives us 51 meters per second, and that's our answer. It's just as straightforward as that. So, on to number 13. We have this missile that is fired horizontally from the top of a building, and let's just draw our building. So it's fired horizontally, and of course as soon as it does that, it starts to travel downward and maintain its horizontal velocity as 50 meters per second. So Vx will always be 50 meters per second. What we want to know is how much time does it have to gain velocity. And for this we're going to use the formula d is equal to v naught t plus 1/2 a t squared. And this is for dy then. And obviously all of these are going to be in the y direction. And for our purposes then, since it was launched horizontally, the v naught in the y direction is equal to 0, and the formula simplifies to be d is equal to 1/2, and let's make this a g so that we know that we're talking about gravity, multiplied by the time squared. And since we want to know time, we rearrange the formula. We would say t is equal to 2 times the square root, the square root of 2d over g. Plugging our numbers in, 2 times the 78.4 divided by the 9.81, square root the whole thing, you get 4 seconds. It wants to know how far is the horizontal range. Well, what that's really asking is how far did it go from the base of the building. Well, remember, Vx was 50 meters per second. Since t is equal to 4 seconds, and since it is constant, we can simply say that dx is equal to Vx times t. We get 50 times 4, 200 meters total travel distance from the base of the building. Like that. Okay, and let's look at number 14 here. Okay, number 14. And a rock is thrown horizontally with an initial speed of 41 meters per second from a cliff. Sounds similar to that one, right? 32 meters, and it's 41 meters per second. That. What is the velocity of the rock at the moment of impact? Let's just figure out what our vertical velocity will be after falling 32 meters. We can simply say Vf squared equals Vi squared plus 2AD. Since it was launched horizontally, the initial velocity is 0. Vf then becomes the square root of 2 times the acceleration. It's due to gravity, so it's 9.81. multiplied by the distance that it falls, 32 meters, we get a VF of 25 meters per second after that distance. And since our horizontal velocity is still 41, and now we have this component in the y direction, the vertical, of 25, we want to know what is the total velocity. A little bit of Pythagoras, just like that, gives us 48 meters per second below horizontal. Now if we want to know the angle, of course we just arctan, so if we do this we get 31 degrees. Our choice then is C. And let's do one more. So question number 15. A baseball thrown vertically upward into the air. What is the instantaneous acceleration at the highest point? What you need to realize is that the acceleration is constant, no matter where it is in this trip. So on the way up, the acceleration is downward at 9.81. At the top, even though it's stopped, it's 9.81. And on the way back down, it's still 9.81. So that's our choice, 15. The answer, A.